Hello everyone. Today we're going to be looking at Unit 6, Geometric Mean Notes. So let's take a look at our learn. So the geometric mean of a set of numbers is the nth root, where n is the number of elements in the set of numbers. So our key concept is the geometric mean of two positive numbers, a and b, is x such that a divided by x equals x divided by b. We can cross multiply that and get x squared equals ab. And we can take the square root of both sides, leaving us with x equals the square root of ab. We have some theorems. So our first theorem, theorem 4.1, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Theorem 4.2, geometric mean altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this altitude is the geometric mean between the lengths of these two segments. And then our last theorem, theorem 4.3, the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the legs of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So let's go ahead and start to look at example 1, find the geometric mean. So we want to find the geometric mean between 5 and 45. So using that formula of x equals the square root of a times b, 5 is going to be my a value, 45 is going to be my b value. So that's going to give me the square root of 5 times 45. Well, 5 times 45 is 225. 225. And if I take the square root of 225, I actually get a whole number out, and that whole number I get out is 15. Sometimes I might not get a whole number out, sometimes I might. I just got to take the square root and figure out what I get. So write a similarity statement identifying the three similar right triangles in this figure. So we have one right triangle, as you can see, is QSR. That's one of our right triangles. So let's start with drawing that one. So the right triangle is going to be Q, S, and R. Another right triangle that we have is Q, T, S. So another right triangle we have is Q, T, and S. But because we have that this is a right triangle, this side over here is also going to be a right. So that means STR. So STR. So those are all of our right triangles. These got to be flipped. QTS. There we go. So those are our three right triangles. So by theorem, (3.1) triangle STR is similar to triangle QTS is similar to triangle QSR. All right, let's take a look at example 3. So we have this triangle. What we want to do is we want to find the value of x, y, and z. So x is right here between A, B. Y is going to be BC, and z is going to be BD. So x. Well, x is the leg of our triangle. So since it's the leg of our triangle, x is the geometric mean of AD. So it's going to be adjacent to AB and BC. So x equals the square root of AD times AC. So that's going to give me the square root of 8 times, well, AC is this whole thing, so that's going to be 8 plus 25. 8 plus 25. Well, 8 plus 25 is 33, so it's going to give me 8 times 33, which is the square root 264. So this one, when we take the square root of this, is not as nice as the last one. This is going to give me 2 root 66, which is about 16.2. So that's what our x is. Now let's take a look at our y value. So our y value is down here at the bottom. So our y is the leg BC. Y is our geometric mean of DC, measuring the segments of BC and AC. So this is going to give me y equals the square root of DC times AC. So DC is 25. So it's going to give me the square root of 25 times AC, which we had from before, is 8 plus 25. So that's going to give me the square root of 25 times 33, which is going to give me the square root of 825. Again, it doesn't give me a nice number. It's going to give me 5 root 33, which is about 28.7. Now let's find z. So z is the measure of the altitude drawn to the hypotenuse. So the altitude drawn to the hypotenuse of the triangle ABC. So z is the geometric mean of the length of the two segments AD and DC. So z is going to equal the square root of AD times DC, which is the square root of 8 times 25, which is going to give me the square root of 200, which again, when we do this, is not going to give me a precise number, 10 root 2, which is about 14.1. So when we plug in our values, we end up with 16.2, 28.7, and 14.1. So let's take a look at our next example. So example 4. So Diego wants to find the height of a half-pipe ramp at a skate park near his house. To find the height, Diego holds a book up to his eyes so that the top and bottom of the ramp are in the line with the bottom edge in the binding of the book. If Diego's eye level is 5.5 feet from the ground and he stands 6 feet from the ramp, how tall is the ramp in the nearest feet? So he's standing 6 feet away from the ramp. His height right here is 5'5". So we're going to use our geometric mean to find our altitude. Because we have our altitude right here of 6, we know that this part is 5.5, so we're going to solve for this part. So when we plug in for our geometric mean, this is going to give me 6 equals the square root of 5.5 times x, because we need to multiply these two numbers to get what our mean is right here. So I'm going to square both sides. That gets rid of my square roots. That gives me 36 equals 5.5 times x. Now I'm going to divide both sides by 5.5. Divide by 5.5. That gives me 6.55 equals x. So that means that that second part, the top part of it, is going to be 6.55. So this part right here is 6.55. To find how tall the whole ramp is, it's going to be 6.55 plus 5.5, which is about 12 feet. The precise number is 12.05, but we're just going to round it to 12 feet. Another name for this would be the hypotenuse, because right here we have our right angle. Opposite our right angle is our hypotenuse. We've learned that before, and we're going to go through that idea again. So again, we used the geometric mean in this lesson. We had 3 different theorems, so review 3 theorems and write a summary for those.